Welcome to qnawire.
Hi, so over here we're asked to employ these observations in order to find the sign of enthalpy and the entropy for the reaction. So first of all, remember that delta G for a reaction is going to be equal to delta H minus T times delta S. And for a reaction to be spontaneous, the value for delta G needs to be lower than zero to have a spontaneous reaction. So for the first reaction A that we're going to have is that the reaction is going to be only spontaneous at below minus 43 degrees Celsius. Remember that the temperature is not going to have a negative sign because this we need to convert it into Kelvin. And this in particular would correspond to a temperature in Kelvin of 230 Kelvin, right? So what is going to occur is that for the delta G to be lower than zero, only below minus 43 degrees Celsius, what needs to happen is that delta H needs to be lower than zero, and delta S is going to be also lower than zero. That means that the reaction at low temperatures is going to be spontaneous, since the absolute value for delta H is going to be larger than the absolute value of the T delta S contribution. So for the first case, we're going to have delta H is going to be negative and delta S is going to be positive. Now, for the second reaction, we're told that the reverse of this reaction is always spontaneous, but proceeds faster at temperatures about minus 15 degrees Celsius. Remember that delta G is only going to be related to know if a process is going to be spontaneous or not, or to the equilibrium constant. It is not going to be related to kinetics. So, in this case, if the reverse of this reaction is always positive, that means that the forward reaction is always going to be non-spontaneous. It is always going to have a delta G larger than zero regardless of the temperature. That means that delta H is going to be positive and delta S is going to be negative, since that combination gives us a delta G larger than zero for all the range of temperatures. And next, we're going to have a reaction that is going to be spontaneous only above minus 38 degrees Celsius. So for reaction C, remember, the temperature is always going to be positive because we're dealing with absolute thermodynamic temperatures. We need to always transform the temperature into Kelvin. But what we're going to get is that the reaction is going to be spontaneous only at higher temperatures. And what this indicates is that the delta H is going to be lower than zero. The delta H is going to be larger than zero. And delta S is also going to be larger than zero. Thus, at higher temperature, the contribution corresponding to the absolute value of T delta S is going to become larger than the contribution corresponding to delta H. And to overcome that the reaction is going to be non-spontaneous at lower temperatures than minus 38 degrees Celsius, this needs to be the proper combination. So delta H is going to be positive, and delta S is going to be positive as well. And with that, it would be all. Thank you very much, and have a good one.